Today we'll look at the superposition of electric fields. Well, over here we have a dipole, which is basically a positive and negative charge at the same magnitude. And suppose we place a positive test charge between those two charges. So the negative charge is going to attract this positive charge. So we're going to have a radial force towards it. And the positive charge is going to repel this positive charge. So these forces are going to be equal in magnitude because this charge is at the same distance from those two. And therefore the net force is going to be something like this. Now suppose we place our positive test charge somewhere here. Well, therefore we're going to get a radial force towards the negative charge, but that's going to be smaller in magnitude because this point is further away from this charge than this point over here. Now from the positive charge, we're going to have a repulsive force. So that's going to act something like this, radially from this charge. And if we're using the parallelogram rule, we can sum those up to obtain the net force on that positive test charge. So if you do this at many points, you'll be able to obtain the electric field lines. So for example, the electric field lines will look something like this. And then something like this. And similarly, the electric field line up here is going to look something like this. So it's going to be symmetric because we have a dipole. And the net force on a test charge placed in the electric field will act tangent to the line. And note that for positive test charges, this force acts in the direction of the electric field. Whereas if this were a negative test charge, it's going to be repelled by this negative charge, and the force will be tangent to the curve, but act in the opposite direction against the electric field. So this is really the basic idea of the superposition principle, and we can visualize the forces acting on test charges placed in the electric field. And I'll see you in the next video.